whatnot. And with that, I'd like to turn it over to Jim McQuillan to introduce our speaker.
Yes, so tonight it's my pleasure to have a presentation from Josh Berkus. I've known Josh for like, I don't know, 20, 21 years, back in the days of Linux world.
And LTSP.
Yeah, we used to do the LTSP booth at Linux World, and I think that's where I ran into you. Back then, were you involved somehow with OpenOffice at that point?
Yes.
Or was it? Yeah.
I was one of the original OpenOffice community team.
Yeah, and so we used to, with my LTSP, the thin clients on Linux, we would supply computing service to OpenOffice at the Linux World booth, so that they were running our thin clients, demonstrating their fine word processing software with OpenOffice.
Yeah, we even got to set up a school in California actually with LTSP and
OpenOffice. Back in the good old days. So then you went on to Postgres. You were like community manager for Postgres? Is that right?
I was on the core team.
Okay.
Mainly worked on configuration and performance. And Postgres lasted me through several different companies.
Yeah.
And then I got interested in this whole Kubernetes thing. So
so now you're at Red Hat. Your title is
Kubernetes Community Architect.
Okay. So, and you're going to tell us a little bit about that and some cloud native stuff, and I don't know what else. Just it's going to be an interesting.
A whole bunch of stuff. Although I will warn people that if you haven't already eaten before the meeting, you probably want to break out your snacks for the meeting.
Oh, geez.
And mute your microphone. Just a friendly warning. So let me go ahead and share my screen.
Yes. So I will turn this over to you. Go ahead and impress us.
And by the way, while I'm sharing my screen, I can't see comments. So if a question comes in via comment, then somebody will need to read it out to me.
I'll read it out. Yeah.
So. Okay. And here we go. Is that coming through okay?
There we go. Yep.
Yeah, looks
awesome.
Beautiful.
We are go flight.
Yep.
The slide loaded fully.
Yep. So this whole presentation is kind of an orientation into what is this whole cloud native thing from a practical basis. For those of you who already have like direct experience with Kubernetes and with doing stuff on cloud native stacks, I will try to keep it entertaining enough that'll be interesting to you anyway. And I might even tell you some things you didn't know. So I'm Josh Berkus. We talked a little bit about my history. Currently, I'm a CNCF ambassador, which means I go around promoting cloud native things. I'm co-chair of TAG Contributor Strategy, which tries to manage all the contributors across the ecosystem. I'm also chair of a Kubernetes SIG, which is Kubernetes' groups. And I work on Kubernetes for Red Hat. So I am all in on the cloud native stuff. So with that, we want to ask, what's cloud native, right? This is important. By the way, this is kind of a little prep. For those of you who didn't already know, KubeCon / Cloud Native Con is coming to Detroit in October. So the big conference for the whole cloud native ecosystem will be right here in Michigan. And so hopefully this will give you a little bit orientation towards what that's about if you or your employer can spring for a ticket. So what is this cloud native thing? Well, there's a definition on CNCF.io, the Cloud Native Computing Foundation's website. But like a lot of these other sort of definition mission statements and stuff, doesn't really help. We got sort of containers and microservices and immutable infrastructure in here and some automation stuff. But honestly, that could describe pretty much any sort of modern ops software. So it doesn't tell you a lot. So maybe what we should do is we should look at which projects are considered cloud native. Well, on CNCF.io, they have this thing called the cloud native landscape. And you quickly are confronted with the fact that there are over 140 projects, I think, in the CNCF itself, plus a whole bunch of other projects and products and companies that are considered cloud native ecosystem, to the point where it starts looking kind of like the entire world of current open source software. So that doesn't really help us understand this cloud native thing. So let's go for some other simpler definitions. The first thing is cloud native is a stack. It's an application software stack that you can run your application software on. And you've got a bunch of different components that go into that stack, you know, that run on top of whatever software, hardware, or hosting that you have in order to run a whole bunch of other stuff on top of it, right? So in this way, cloud native Kubernetes kind of replaces some older stacks, right? You know, when we first started this whole Linux thing, we had stuff like the LAMP stack. You know, we ran everything on individual servers, and then people started wanting to run stuff on multiple servers, and you got things like vSphere and AWS and OpenStack and other virtual machine-based platforms. And then we moved to containers, and we got this sort of Kubernetes-based stack that's called cloud native. Except that's a little deceptive because we actually never threw any of the old stuff away. And in fact, everybody is mixing and matching and running the new stuff on the old stuff and the old stuff on the new stuff, and all of that other stack thing, because it's the world of software. We never throw anything away. We just add more layers on top. So, okay, so it's a stack. But how do I really understand the elements of the stack? How does that get me to an explanation of those 140 plus projects so that I can make some kind of sense of what I need and what I don't need? Well, one way you can kind of look at it is it's kind of a solar system, right? With Kubernetes at the center and a whole bunch of other projects orbiting around. But problem with that is it doesn't really help you make choices, and you have to make choices because you're not going to use all 140 projects. So I think there's actually a better metaphor here, and that's a burrito menu. See, this is why I warned you to get your snacks out. Because the lovely thing about burritos is you have a lot of options, right? You can figure out your protein and your rice and beans and your salsa and your guacamole or not and that sort of thing, and cilantro or not, and vegetables and other stuff. And you have a lot of choices, but what you end up with is still a burrito. Most of the time anyway. And you can like even be super creative with your choices. And sometimes you can even go outside the realm of, okay, well, I'm going to actually use a lot of these same choices and make something that isn't a burrito. That's a bowl or a salad. Or maybe I'm going to take a whole bunch of really weird things and wrap them in a tortilla and make my own super creative, very out there, very around my special needs burrito. That is an infamous John Scalzi burrito made with marshmallow fluff, peppermint, strawberry jam, and gummy worms. And I feel like this is really kind of helps you get more of a grip on looking at what is this whole ecosystem of projects, right? Because you can say, okay, I need to have some of these things, but even for the things I need to have, I often have alternatives for which project exactly I use. And then there's a whole bunch of things that I only include if I actually need them, right? Like you only put cilantro in your burrito if you actually like cilantro. And the number of combinations are not actually infinite, but they're very large. So we're going to walk through this And we're going to spend the rest of this presentation walking through our whole suite of ingredients for our cloud native burrito to help you make some sense of what the options are and how the various projects fit into the ecosystem, so that when somebody says to you, hey, I really think we should have a Kuma service mesh, that's going to actually mean something. So our first sort of core thing, right, we're going to talk about, right, what is it that essentially makes something a burrito, right? It's the wrapper, right? It's your tortilla. So what is our tortilla? What holds everything together? Well, that's Kubernetes. Also etcd, because etcd is the distributed consensus database that stores Kubernetes' data. But Kubernetes kind of holds everything together. Now, how most people have Kubernetes explained to them is as an orchestrator, which it is, right? So you tell Kubernetes, hey, I want you to deploy 3 instances of NGINX running the simple web application, and it's going to be talking to 2 instances of the Redis database, and please distribute those across my hardware. And Kubernetes handles that for you. It says, okay, who has space to run these things? We're going to drop those on there. You can add things like preferences and affinity, so it doesn't put them all on one physical node. And it figures that out. And that is something that Kubernetes does, and fairly important for the understanding of this orchestration principle. Or if you, because I know we have some old Unix people on this, Kubernetes is a scheduler for clusters. Now, we have one specific component within Kubernetes that is called the scheduler. But in the larger sense of your scheduler stack, what Kubernetes is doing is not different from what we used to do in terms of timeshares in back systems back in the day. It's just doing it over a much larger array of hardware. But Kubernetes has another very important function within this cloud native ecosystem, and it's the API, because that's actually the inalienable part of Kubernetes. The scheduler can be swapped out for something else. The controller, which is what actually deploys applications and containers, can be swapped out for something else. Pretty much everything in Kubernetes can get swapped out for something else except the API. The API is what definitionally makes it Kubernetes, and that API ties together all of the various projects and technologies within the cloud native world. So you can basically strip out everything else in Kubernetes and just use it as an API server to talk to other things. And that's why it is the sun in our cloud native solar system, whose gravity holds everything together. It's that API. Now, that doesn't mean it's completely irreplaceable, though, because you might say, well, but what if I don't want a burrito? What if I only want a taco? Well, there's options there, because you can use this little Kubernetes distribution called K3S, which is a lightweight mini Kubernetes, in order to make your taco scale Kubernetes. And there are a few other options there, like Kubernetes Edge for weird hardware and that sort of thing. So, in our burrito, taco, salad, bowl bar, everything is potentially swappable. So, having settled our tortilla, let's go ahead and talk about our sort of inalienable components. Inalienable, not that you have to use specific components, but you have to have something in their place. And this is what I call our rice and beans, which are sort of our staples to bulk out the burrito. And you have your choice of flavors there, but most of the time these are a requirement of your Northern California burrito anyway. And that would include container runtimes, virtual networking, storage, and cloud provider tooling. And I'll explain what all these are. So for the container runtimes, you basically something needs to launch the containers on each node. So Kubernetes talks to the nodes and it says, hey, I want a container running Postgres on this node. And something actually needs to fire up a process in a namespace, which is what a container is, and make it run. And our main options for that are two tools called Cryo and Containerd. But there are other options, some of which I will be mentioning later. A lot of people say, oh, well, that's Docker, of course, but it's actually not anymore, because Kubernetes only wants to talk to the server portion of Docker. And the Docker project folks separated that out, and they made Containerd. Because Docker has a lot of other tooling for developers and other things that are not relevant in a Kubernetes context. And so that got separated out into Containerd. And there's some alternatives I'll be talking about later on when we get into topics. Now, your second thing is you need a virtual network, or a network overlay, as it's called, right? Because you need to be able to send traffic from one container to another, right? You need to be able to say, hey, my Python application needs to talk to this Redis database in my cluster. And this is one of the areas that from the earliest days of Kubernetes already had a whole bunch of options. And this includes things like Calico, Cilium, Open Virtual Network, a bunch of other things, some Tigera, and some proprietary products. We also need the other portions of the network stack, such as discovery, with things like Core DNS and K3GB, that actually handle the, hey, I need to find these services running on Kubernetes by name. Things like routing, so that requests that come in get to the right service. And that includes things like Ingress and Contour. And then you also probably, if you have multiple clusters, you want some kind of wide area network. And that's done through networking that spans clusters, things like Submariner and Antrea. So you can see already we're kind of assembling our stack within a stack, right? So within Kubernetes and Cloud Native ecosystem, we have our own network stack. And one of the things about this is you use a lot of these network tools together, right? You wouldn't use all of them, but you might use several of them. Plus, some of them, as we'll be getting into, also serve other purposes at the same time as they're providing whatever their network function is. You also need some kind of storage. This was one of the ways that Kubernetes kind of took over early on from pure Docker, which is it handled storage, which you kind of needed if you're going to run things like databases and file servers and caches and other things on top of Kubernetes. And because Cloud Native wants to be able to move services around, it wants to be able to move containers from one server to another with impunity, it means that you need some kind of cloudy storage that can move with the services that are using the storage. And so this includes projects. First of all, what this works through is something called CSI, which is Container Storage Interface, which is a spec and a project in its own right that explains how containers connect to storage. And this allows a plug-in infrastructure that allows people to be very flexible and very creative around how they actually implement the storage, including projects like Rook that handle deploying the Ceph distributed storage system on top of Kubernetes, OpenEBS, which provides an Amazon-like interface to a variety of different storage backends, and Longhorn, which is another distributed storage project. Finally, Kubernetes is a stack. Kubernetes and Cloud Native is a stack, but it's not a complete stack. It doesn't handle stuff kind of on the hardware and hosting layer. Doesn't handle stuff, below a certain amount of Linux kernel calls, et cetera. It all operates in user space. So we actually need some layers below that. Now, one of the common ways to handle that is a lot of people actually run their Cloud Native cluster, their Kubernetes cluster, on top of a public cloud. And when they do that, they will use a variety of plugins that are available, not as completely separate projects, but as optional components for Amazon or Azure or Google, GCE or DigitalOcean or whatever it is they're using. If you're running your own private cloud, you might use something like an OpenStack or Cloud Foundry or vSphere plugin. And if you want to run it on top of bare metal, because you're like, hey, the whole reason why I implemented this in the first place was I want to supply my own hardware and control my own hardware. Then there are tools like MetalLB and MetalCubed that allow you to treat your hardware like a private cloud. So we've got our wrapper, Kubernetes. We have our rice and beans, you know, our basic sort of hardware, virtual hardware support. So now, what are we going to fill our cloud native burrito with? Right, and this is in burrito land. This is normally called the protein. And here, what I'm saying is, hey, the whole reason why we built this thing is that we want to run applications on it, right? That's the whole point of this. There's no point in having a cluster just to have a cluster. And so there's a lot of different ways to do this. One of the simpler ways to do this is there's a tool called Helm, which is tremendously popular. And it's basically a tool for scripting application deployments on Kubernetes. Now, you can do these by hand on Kubernetes. Kubernetes accepts YAML files from anybody who's like knows the YAML markup format, which dates back to Perl. And you can do that, but that's not really a production way to do things, because you need ways to actually script stuff, to introduce variables, to introduce instances. And so the simplest way to do this is something called Helm, which is this sort of scripting templating interface on top of those deployments. Now, this doesn't necessarily scale across very large development teams and a whole lot of different activity by itself. However, some of the other application tools embed Helm as a component in how they do things. So speaking of those, one of the big reasons why people adopted Cloud Native in the first place was that they wanted to do continuous integration, continuous delivery better, right? One of the things that containers delivered for people was faster builds, faster deployments, which help you do CI/CD. So it's not a surprise that there's a whole bunch of CI/CD tools which are intended for use with Kubernetes. And these include tools like Argo CD and Flux and Jenkins X and Tecton and Shipwright. And all of these help your development teams or the development teams you work with bring together, their pipeline to go from building code to deploying it to test and staging and production. And like a lot of other things you'll experience in Cloud Native, these aren't necessarily exclusive alternatives. Like Argo CD actually can work together with Tecton. Flux can work together with Shipwright. It's, a whole bunch of options, many of which can be combined. Now, one of the other things, and again, this can be combined with other stuff, is you can say, okay, CI/CD is nice, but I really want my applications to manage themselves, right? I have all of this code, I have all this knowledge about how to automate things, and I want to make use of it to do maximum automation. And this is where we get into operators. And this is where you use Kubernetes' own programming the cluster infrastructure called CRD, which stands for Custom Resource Deployment. And you can turn an application, a business application, a user application into a Kubernetes object. Or if you don't want to do a whole bunch of work from scratch yourself, you actually download and modify one from Operator Hub. Now, again, this is a combined thing, right? Because one of the primary ways to deploy operators these days is to use Helm. So people still do a lot of mix, match, and combine. Okay, we have our burrito, we have our wrapper, we have our rice and beans, we have our protein. What else does a burrito need? Cheese, of course. Or, if you're vegan cheese. And what I'm going to call our cheese is observability here, because we have a whole nother sort of stack around observability. Now, if any of you are in the SRE observability realm and stuff, you're probably familiar with this 3 pillars model of metrics, traces, and logs as being the 3 sort of inputs for observability. And all of these things have been implemented within the cloud native ecosystem. So for metrics, we have projects like OpenMetrics and Pixie. For traces, we have actually a whole bunch of different projects in the trace realm, including Jaeger and OpenTelemetry, and one of the reasons why you need special tools for these for observability is a matter of scale. Because a lot of sort of classic observability tools designed around hardware servers or VMs are not designed around the numbers of instances you're dealing with when you move to a container infrastructure, which generally involves moving up kind of an order of magnitude the number of sort of, say, application instances you're dealing with. Plus, a lot of those instances are very short-lived. So, you know, if you're going to have, it's sort of a qualitative difference between having, say, 10 physical web servers versus having 1,000 web servers, many of which only last for an hour. And so you have to redo a lot of your observability tools to work in this environment. And so you end up with tracing, for example, needs to take into account the fact that the container that you are tracing may have ceased to exist by the time you look at the traces. And so tools like Jaeger and OpenTelemetry can collect traces in that environment. And for logging, obviously, you have potentially really tremendous log volume. And as a result, we have sort of last generation large-scale logging tools, the most used of which is Prometheus, which has an optional storage tool to manage the enormous amount of data that it generates called Thanos. Now, that said, a lot of the newer observability vendors, companies like Datadog and Sysdig, have tools designed to monitor cloud native. So with that, let's get into toppings. And before we do that, let's do a pause for questions. Have we accumulated any questions here?
I'm not seeing any questions in the chat, but that doesn't mean that there aren't any questions. Are there any questions out there? Feel free to raise your hand using either, you know, the physical hand or the raise hand feature down at the very bottom. Going once, going twice. Where are the chips?
Okay. Yeah, where are the chips? Yep.
That's coming up.
I'm going to get into toppings, and I call these things toppings simply because we're now getting into the realm of things that you might or might not have in your cluster at all, depending on what your needs are. You know, just like you might put cilantro on, you might put salsa on, you might put mango on, depending on whether or not you want it and whether or not you need it. And then, of course, for each item, you have, you know, a large number of choices, right? We can have our mild salsa, our hot salsa, our tomatillo salsa, all of these different things. So, and I'm not going to cover everything. And so, by the way, something in general, which is for sort of every different type, every different, you know, role or whatever that I have in here, I'm just giving you a few examples. There are more projects than the ones that I mentioned. And this is definitely going to be true as we move into this. So I would say sort of your toppings, your optional components. I'm going to cover sort of 8 areas that are the primary areas where you have a bunch of different projects that are available. There are a few other things that are not, you know, I'm not going to mention because I don't want to cover the entire universe. But this will give you kind of an orientation around other sort of optional stacks you might tack on. So one of the big things, obviously, is security. Now, Kubernetes has a certain amount of security and isolation controls built into it. And by the way, that picture is actually of something that was just announced yesterday, which is burrito tape. It is an edible tape invented by some students at Johns Hopkins to make sure that your burrito stays closed. But that level of security, the built-in stuff, is often not enough for cluster operators. So let's talk about what else is available. And this is one of the areas where you have the largest amount of diversity, because basically, as well as sort of new vendors and new projects, every old security vendor also very quickly went to market developing a open source project or a product around helping provide security to cloud native. So we have things for every sort of different security role that there is, and many options in many cases. So for example, for security policy, we have Open Policy Agent and Open Cluster Management Policy and Kyverno and some other projects for identity and secrets management, Keycloak, Vault, Cert Manager, Spiffy Project. We have network security tools. And so now you're going to see some things that appeared earlier, right? I had both Calico and Cilium in the network section. Well, those networks are specifically designed around restricting and segregating access and auditing. And for that reason, they're also security products. There's the Confidential Containers project that is building a standard and tools around keeping the contents of containers secret from other users in the network. For your DevOps crew, there's Kubelinter, which scans a lot of your deployments to look for problems. For threat detection and management, you have projects like Falco. And if you want a security framework that integrates a lot of these tools into sort of a single security management tool, you have stuff like StackRox. Now, one of the other things you'll have heard about, if you've heard anything about Cloud Native, is you've heard service mesh. And if you are not active in this ecosystem, your second thing is, okay, so what's a service mesh? And a lot of the explanations probably didn't help. So I'm going to try to make sense of it for somebody who just really wants to know, how does this fit into my picture? And so basically what a service mesh is you're collapsing several network layers, specifically most of layers 4 to 7, into a single tool in order to centrally control and monitor network traffic, both on a granular level and on sort of a batch level. So what you do is you have a configurable proxy somewhere as part of your tool, and that can control discovery and routing and network sessions and even identity within your cluster through the management tool that is part of your service mesh. And the reasons why people would want to do this are to do things like A/B testing, right? Send half my traffic to the new version of the application. Or traffic status, right? Where is all of my traffic going, right? The network is extremely busy. What's being used? You can use service message for bridging between clusters. You can use them to help do live migration, even including upgrading the version of your cluster itself. And of course, service meshes can also be a security tool, particularly for multi-tenancy situations. So there's a bunch of choices in the service mesh realm. You can use Istio with Envoy. You can use Contour with Envoy. You can use OSM with Envoy, Open Service Mesh with Envoy. You can use Kuma with Envoy. You might notice a pattern here. So what the pattern is Envoy is a proxy that runs together with your containerized applications on each node. As a matter of fact, in each what's called a pod within Kubernetes, which is a group of related containers. And that actually handles the network traffic for that specific group of containers individually. And then Envoy communicates with a management console, a management tool, which could be Istio, a Contour, Open Service Mesh, or Kuma, in order to perform those higher level functions of deciding, hey, I want to do A/B, application testing. I want to migrate to a new Kubernetes cluster and bridge all my traffic to that new cluster. Any of those things that you're going to do that involve the cluster are going to be routed between Envoy and its management thing, unless you're using Linkerd. Because Linkerd, which is actually the oldest service mesh at the venerable age of, I think, 4 years old, has its own proxy that works slightly differently from Envoy. But pretty much everybody else uses Envoy. Now, the other thing that we get that people like to talk a lot about within the realm of cloud native and other stuff is serverless, right? So what's serverless? Well, one of the reasons why serverless is often as confusing as service mesh when people try to define it is there's actually kind of two different sides to it. Now, the one that most people intuitively understand or jump on is what we call function as a service, right? Where you can write a piece of code and then you can send that code to a cloud without like intentionally building a container and then execute it via a function call. This is how in the proprietary realm AWS Lambda works. It's kind of the general conception of what is serverless, right? Is, hey, instead of building a container that has all my application code and makes calls internally, instead I deploy each function or class to the cloud and they call each other across the cluster. But there's a whole nother side to serverless, which is events, which is one of the other things you can do once you have this cloud native cluster is you can do cluster-wide asynchronous programming where instead of a user calling an interface and that interface calling a code stack and that code stack doing a bunch of things until it's done, instead what happens is events happen on the cluster, right? Like somebody hits a web page and then that event communicates through an events interface and spawns, you know, code, containers, function instances, or whatever to deal with what happened. And this is what's called event-driven application design. It's a little harder conceptually, but it has, in my opinion, a much more interesting future in the future of programming because it turns out that from the perspective of the user or the business, a lot of applications that we talk about kind of actually work in an event-driven way conceptually. And so making them work in an event-driven way in terms of code is actually really useful. The other thing that we actually do a lot with serverless is what we call workflow automation. So I mentioned earlier on Tekton, which is a CI/CD tool that allows people to automate their, okay, build this and test it and deploy it and everything else. Well, under the hood, Tekton uses serverless tools to do that automation. So we've got a bunch of tools in this realm, there's actually more sort of consolidation and consensus than there is in some of the other realms of cloud native. Knative does both events and functions. Cloud events is a specification for how event communication should happen on a cluster, which is really useful because events are generally polyglot, right? You have applications written in different languages that are communicating with each other, and therefore you need a strong specification so they can communicate. But there are some other tools. There's OpenFast from the Apache Foundation, which does serverless functions. There's Dapper, which is another cloud native application that only does events. And one of the things that happens when you have an event-driven architecture is that you need some way, you need a pipeline, you need a queue to communicate events across the cluster so that containers running code don't have to connect to each other directly. And so you generally are going to use what's known as a streaming database. And one of the ways to do that in a cloud native cluster is Strimzy. Speaking of databases, it turns out that in the extremely ephemeral, nobody's sure what's running where, etc., very detached from the actual hardware atmosphere of a Kubernetes cluster, it takes some special extra steps to run databases because databases like to know their hardware. They like to stay put in wherever they've been deployed. And so you have to do a lot of other things to make them happy in a cloud native environment. So there's a bunch of tools for that. And you also want to gain things from that cloud native environment, like high availability, right? Which says as long as the cluster is up, somehow the database is also up. So we have a variety of tools there. Some of these tools are brand new databases, like TIKV, which is a brand new distributed database designed for the cloud native environment. And other ones are what we call loosely shims, as in they take an existing database and they supply all the plumbing necessary to make it work well in a cloud native environment. And Vitess is a tool like that, which works with MySQL. And one of the primary uses of operators that I mentioned earlier is to actually run databases. And so, for example, there's like 6 different operators, 6 different public operators for running Postgres in a cloud native environment. Also, if you are running your applications on a Kubernetes cluster, you're going to be doing a lot of building of what are called container images. This is how we distribute containerized applications. It basically replaces RPMs or debs or whatever other packaging you would have used without containers. And if you're building a lot of containers, then you start looking for tools to help you do it better, faster, easier with less management. And of course, there's a whole bunch of those tools. And this is where classic Docker comes in, right? Obviously, the original container building tool. Not the original one. LXD actually preceded it, but the original one that anybody knew about. Plus, more recent tools that are designed to integrate within a CI/CD pipeline, things like build packs, source to image, backstage, dev file, and porter. And once you have all those images, you're going to want to put them into a network service so all the nodes on your cluster can pull down the images that they need when they need them. And sometimes, often if you're running a large cluster or a large infrastructure, you're going to actually want to host your own image server because, you're doing this for development, you're hosting a small cluster, often you use a public image server, one Docker Hub, Google GCR, GitHub images. There's a bunch of public ones available. But if you're running a large production infrastructure, you're going to want to host your own internal image registry. And so in that case, you're going to use something like Harbor or Quay or Dragonfly, which are all ways to run it yourself. Also, I've spent all this time talking about containers, but sometimes you want to run containers that aren't actually containers. That is, you want to take something that is not classically defined as a Linux container and still run it using this cloud native environment. That might be, for example, a virtual machine, in which case you might want to use something like Kubevirt or Kata containers. It might be a WebAssembly runtime, in which case you might want to use one of the Wasm tools in order to run it. And you might want to run your Kubernetes somewhere that doesn't look like a classic rackable server. In which case you might want to use one of these alternate tools for supplying the individual node tool for Kubernetes, like Krustlet, which is Kubernetes rewritten in Rust, Virtual Kubelet, KubeEdge for, your oddball hardware. And then, of course, when you've done all of this, you need to manage all of this stuff. So, of course, people are supplying projects that have very broad management interfaces to try to give you a single pane of glass that you can look at to manage all this stuff you have in your cluster. And a single API that you can write to instead of writing to each project's API. And so this includes things like open cluster management, Crossplane, Kepton, and Argo, the general project, which is a management tool that Argo CD is only part of. But people use a lot of Argo CD by itself. Now, you might be saying, oh my God, that's a lot of separate tools. I really wish that somebody would just take what they regard as the best 15 tools and put them together for me and just hand it to me on a plate, right? It's just like you look at the full set of options in the Chipotle menu and you're like, don't you have a Santa Fe burrito or something? that you can just give me. I don't care what's in it. I just don't want to have to make all these decisions. And of course, there are people that are happy to help you do that. As a matter of fact, that's one of the major business models within the cloud native space, right? There's way too many options and tools. It's easier to pick an opinionated stack, and also integrating everything is a lot of work. Now, within these tools are also called Kubernetes distros. This is actually, after all, after Linux distros, right? Because what was the original purpose utility of a Linux distro like Red Hat or SUSE or Slackware or whatever, right, was they took all of these open source projects and helped integrate them for you, so you didn't have to do everything from source. So within this, there's two kind of options. One of them is there's a bunch of distros generally owned by the cloud vendors themselves for running Kubernetes on top of their cloud. And so this includes Kubernetes plus, this includes Google GKE, Azure AKS, Amazon EKS. You might have noticed there's a trend to call these public cloud distros something with a K in the middle. There are a whole bunch of others. DigitalOcean has their own. Linode has their own. Pretty much if you're running a public cloud, you probably have a Kubernetes tool because somebody's willing to pay for you to set it up for them. But maybe you don't want to run it on a public cloud. Maybe you want to run it on your own hardware. Maybe you want to run it, you want to have one that's cloud agnostic. And in that case, you do what's one of these called one of these hybrid cloud distros, which can be run either on premises in your own hardware or on a public cloud, you know, or bridging multiple clouds. And again, these integrate a lot of the tools that I've talked about. So I work for Red Hat. The reason Red Hat pays me to work in Kubernetes is because we have a distro called OpenShift, hybrid cloud distro, that integrates a whole bunch of developer tools and security tools and a bunch of other things together with Kubernetes. VMware has Tanzu. SUSE has Rancher. There are probably a few others out there, but those are the big ones in the sort of hybrid cloud distro. So, having gone through the burrito ingredients, let's go ahead and wrap things up. So, Cloud Native here is an entire application runtime stack. Like our burrito menu, right? There's a whole bunch of these alternate ingredients offering millions of possible combinations, a few of things of which are essential, but most of which are optional. You can also start really simple and build up, adding things as you need them, or you can use somebody else's recipe or distro to create your own personal stack. So with that, let's take questions. And also remember, we're going to have the entire crowd of Cloud Native folks in Detroit in October.
Any questions out there? I can't imagine there aren't any questions out there.
Okay, I'm going to stop sharing so I can look at chat.
Now, Jim McQuillan, go ahead and just say your wow.
Yeah.
Wow.
Yeah.
There is a lot of stuff there.
Yeah. Well, what's really astonishing about it is that the vast majority of the stuff was built in the last 5 years.
Yeah, that's pretty good. I just started dabbling with Docker, and this goes so far beyond what I'm doing with Docker.
Okay, we have a question from Dave.
Yeah, I wonder if you could possibly go through one implementation of this, and if you could bring one to mind and tell us about, kind of each component of it and what that's doing. This is only about 15 new technologies that I haven't dealt with in the past.
Yeah, well, I mean, the thing is that you can start really small, right? Because I literally have a single node Kubernetes server that runs on a Linode virtual server that I have, just in order to run a bunch of old PHP sites. And because I didn't want to implement cloud native storage, I also run that with Kubevirt. And Kubevirt runs a single VM, and that VM has Postgres in it. So I've got core Kubernetes. I've got it running cryo for container runtimes because I work with the cryo folks and I couldn't not. I have Kubevirt. I've dabbled with some operator stuff on that cluster, but I don't actually use it. And I've got Ingress NGINX set up so that it can accept outside web requests. So because initially when you set up a Kubernetes cluster, everything inside the cluster can talk to everything else inside the cluster. But what it can't talk to is the outside world. And you want to set up a controlled way for it to talk to the outside world. And the API for that is something called Ingress, usually. But Ingress needs a backend that handles the actual web sessions. And so the most common way to do that is to actually use NGINX web server. And so there's this project called Ingress NGINX to route that traffic. And importantly, that handles things like SSL connections for you as well. So like that's my miniature stack that I use to run these old PHP sites as like one implementation example. Go ahead.
Yeah, so I'm overwhelmed, right? But I've been doing this type of thing for a while now, and I've been experienced with some of the things you've talked about. Rancher, I was running Rancher for a couple of years. I didn't know what it was doing, but it just kept running, so I was fine with that.
Yep.
Put in OpenStack and try to build some stuff on top of that. And it's like, okay, do you put OpenStack, then Kubernetes, and something else on top, and like a sandwich, Dagwood sandwich, right? And so you're just talking about your minimum stack and what you were doing just a moment ago. I think that would be a really, really good follow-up, maybe, to just walk through like I don't know, not a personal lab, but a simple lab setup on something like this. So I don't know if we could, get you to come back and give us like, another 45 minutes on here's the, the 5 or 6 things you need to do to get started today in order to, pick your, pick your brain a little bit. That's, just what I was thinking.
Yeah, maybe. And we can also pester some of your more local community because we do have a number of Kubernetes contributors from Michigan. So we got another hand up.
Dale, why don't you go ahead? Hello, Dale. You are on the air.
Yeah, sorry. No specific question. I'm just, I knew the thing was big, but I had no idea just how big it was. And thank you for trying to make it simpler.
Yeah. Well, you're welcome. Like I said, I wanted to give you a map that kind of outlined where the continents were, so that you could figure out if somebody starts talking to you about a service mesh interface or or cloud native storage. It's not totally ancient Greek.
Dave, do you have another question?
No, that was a misclick.
Oh, no worries.
Just one question. Thanks.
That's fine. I guess my one question would be, can you point us to other resources to just get our feet wet on all of this stuff, like a quick summary or something like that, or a reference card or something like that?
Well, one of the things I did was actually try to put together this presentation as such a thing.
Right.
Because I feel like a lot of the so actually here's a link to the presentation itself.
Perfect.
A lot of the resources that we have. So like, for example, within the CNCF, if you go to cncf.io, we have this cloud native landscape, which is interactive. So you can spend a fair amount of time clicking around there, looking at different things. And hopefully you combine the presentation with that to give you some idea of what the sort of areas are in that cloud native landscape. The cloud native landscape people are actually doing a second thing where they're looking at it from the perspective of the journey of an adopter, of saying, hey, you're moving your stuff to Kubernetes, to a cloud native stack. Which things are you going to adopt and implement first versus which things you're going to need later on? And that's not finished yet. But that will also be helpful, kind of when it's there. And honestly, I think most people, what they end up doing for production or for their deployment is they end up using one of the opinionated distros. Because if you've never used it before, then trying to put together all of these components becomes becomes one of those things. If you remember, I find it analogous to back in the day when we had to compile our own Linux distributions. And yeah, a few of us did it, but most people didn't. Most people waited for distributions on CD to come out. And I would still say, even if you have the skills, you want to start with a distribution on CD, which is the OpenShift or Rancher or GK or whatever, to get an idea of what you even want to do. Before you start looking at, okay, we're going to start swapping out all these different components.
Thank you.
Yeah. So there's a question from Ryan here, which is, are the various components written to some abstract interface so deployments can say, I want a network overlay like this without having to know which implementation is under the hood? And I would say, unfortunately, no. And I would say, unfortunately, we're actually quite a ways from that. For the same reasons, honestly, that, say, Linux distributions were a ways from that, right? Because, like, for example, once upon a time, Red Hat tried to do this thing where instead of asking for a specific database, you would ask for a relational database. And then you just get something, which at the time was Postgres. Because, out of their thinking that, hey, most developers didn't actually care what flavor of database it was under the hood. But it turns out that people did care, because even when things serve analogous functions, a lot of the sort of ways they interact with your application are different. And it can get more complicated in this environment because you remember I showed you things like there's the network tools that are also security tools. And so you can kind of put things into these general areas, but there's a lot of overlap, and the overlap is not the same for everything. Because, like, for example, a service mesh can be a security tool, but not every security tool requires a service mesh. So I think the better thing that we're more likely to get in the near future is, as the platforms get more mature, some things will drop out. Is that basically you'll see projects differentiating themselves, where some projects get more mature, more complete, more robust, and at the same time other projects don't, and eventually people stop using those projects. The same way that we have in a lot of other realms, right? Because like I said, I know a lot of examples from the world of databases because I spent so long working in that world. And in 1999, there were probably 40 different viable SQL databases on the market. There are not now. Now there's like 6. And honestly, that reduction was a good thing, because what happened was the 6 ones that we still have got much, much better. And the other ones basically didn't. And so I think we'll see that same kind of thing within the cloud native world. We're in early stages, right? Nothing that I talked about today is more than 5 years old. Any more questions? Yeah.
I was just wondering if you're So I was looking at the user groups out there and some of the Kubernetes things, and it doesn't seem like it's based on the region or the physical location. It's all based on like what tool sets and the interest of the that particular type of software. Is that the general way that works?
No, there actually are a lot of regional user groups. It's just most of them are on hiatus. Most people are still not doing in-person meetups. So I just posted a link in there to the ones that are officially listed with the CNCF. And for example, there are 3 of them in Michigan. There's one in Grand Rapids, there's one in Ann Arbor, and there's actually one in Detroit that is not an official CNCF meetup, and for that reason is not listed here. But most of those have been, kind of on sabbatical. I'm in charge of the Portland Kubernetes user group, but we, have not had in-person meetings for 2.5 years, and we had online meetings for a while, but there is so much online content in the world of cloud native that's kind of global that most of the local meetups have not persisted in trying to have online meetings because they're basically competing with KubeCon and Cloud Native Con and a bunch of vendor stuff and a bunch of other online content. And I'll tell you, it was very difficult trying to compete with that. And so after about a year of doing online meetings, we decided to go on hiatus until we could have in-person meetings again. So the October thing is actually, and that's actually a conference. It's a big conference. I would expect it to be somewhere in the realm of 10,000 people. And let me actually paste one other event in there because KubeCon's going to be huge, and there's going to be 10,000 people at it, and it's also going to be fairly expensive. If you're not entitled to some kind of discount, it's going to be like $1,000 to attend. And so if you're just dipping your toes in, you're probably not going to go to it, even though it's in Detroit, unless you have a very generous boss. So one of the things that's going to be running the weekend before KubeCon is a mini conference called Cloud Native Rejects. And that's a few of the speakers whose talks did not get accepted to KubeCon, give them at this mini con. And that is much cheaper to attend. It might even be free. And will also happen in Detroit over the weekend before KubeCon Detroit.
Are there any other questions out there?
What hotel is hosting that in Detroit?
Detroit Convention Center. Oh, that's actually not called the Detroit Convention Center. What is it called? But it's the big convention center in Detroit.
It used to be called Kobo. I don't remember the exact name of it now.
Yeah, no, and I don't. It's called the Huntington. It's called Huntington Place now.
Yeah, TCF and Huntington's merged. And
I need to get rich so I can name things weird things, like a place or something like that.
Yeah.
yeah.
Yep.
So you're going to be in town for that?
Yep. Absolutely,
Cool.
I will.
For the weekend too?
Yeah, because I usually go to Cloud Native Rejects because they actually often have a more interesting and varied program than we necessarily have for KubeCon because with the large attendance we have for KubeCon, there's a lot of importance on sort of making the presentations mainstream, as it were.
Yeah.
Whereas because Rejects is a much smaller event, they actually often go for the more interesting and oddball talks.
Sure. That one sounds interesting to me. I may try to make my way down there.
Yeah.
I mean, it's only like 30 miles away. I should do it, right?
Yeah. And who knows if we'll ever be in Michigan again,
Yeah. Well, depends on how this one goes, right?
Depends on how this one goes. Well, I mean, one of their worries, right? For ages, they only held KubeCon in the big sort of tech cities, because they were worried that no one would go to one if it wasn't there. But I think we can actually prove to them with Detroit that that's not actually a restriction.
I hope so.
And so then maybe we'll start seeing more in places like Detroit, simply because the convention center is a little cheaper.
Yeah, you got that going for you.
and a little bigger, honestly. One of the nice things about this KubeCon has been we've been asking for extra space for things, and they're like, sure, you can have an extra room, because apparently the Huntington place is huge.
It's pretty big,
Yeah, for the longest time I did the auto show, which is one of the larger shows in the area. Yeah. Our other reason to have it in Detroit is because we do actually have automakers who are doing a lot of the Kubernetes Edge stuff.
Sure.
So
get probably get a lot of attendees from the big three.
Mm-hmm.
That's good. I'll definitely try to make it down there.
I'm looking forward to some pizza and some Lebanese food. So which are the two things I've heard Detroit is good
some
for.
Detroit style pizza. Well, maybe I'll come down there and take you to Buddy's.
Good God, you guys are making me hungry.
Yeah, I told you this is.
I had dinner. That's the thing.
Yeah.
I had dinner, and it's like,
oh my God! Back in the day, Jim and I went down to Brazil, and we just had some amazing meals.
That's right. And Scotty's here on the call tonight too, but he's being quiet.
Hey, Scotty.
Yeah, let's see if he wakes up. But because he's been down to Brazil a couple of times with me too, and it was a great place to go. As I recall, you weren't a meat eater when we went down there.
I mean, I still prefer to avoid meat if I can.
Yeah, but you can't do that in Brazil.
It was tough in southern Brazil, right? Rio Grande do Sul, Texas of Brazil. And the worst one I had was, I did a presentation for the Sao Paulo Linux user group.
Yeah.
And they took me out to eat beforehand, and they took me to a place that basically just serves steak by the kilogram.
Oh yeah.
I can eat a certain amount of meat for the sake of like making my host happy, but not a kilogram.
Yeah. And it's good meat too. But anyway. I'll come down and take you for pizza.
Yep.
I imagine George will be around too. He's still into that stuff.
George Castro. Yeah.
Yep.
Daniel, I will also post the slides when I do post the video up on our website. So in case you accidentally don't remember to click on the link and save a bookmark, we'll at least have that up there, so you'll be able to take a peek at them.
Yeah.
Thanks.
You're welcome. Any other questions or whatnot?
Yeah. Boy, that was excellent.
Yes, thank you so much.
You covered a lot of information in a very in a way we could absorb it. That was great.
I have a little bit of a technical question, I guess, Josh.
Sure, go for it.
etcd seems to be sort of the only option that everyone's using for consensus. And it's probably been 5 years or so since I've looked at Raft implementations. Are there alternatives? Is there any competition in that space?
Yes, there are. I mean, one thing I'll say is that the public clouds that host Kubernetes generally have their own thing that they use. We actually have one of my coworkers actually experimented with and did an experimental deployment of Kubernetes being backed by CockroachDB, which works fine. The main problem with it is that CockroachDB is not open source. So that's going to be limited to people who want to buy a CockroachDB license. I believe Hashi will help you use Kubernetes together with their distributed consensus store, whose name is escaping me at the moment. Console.
I guess I should have been clear. I was
Yeah.
specifically asking for open source options.
Yeah. I don't know. I think Consul's open source. And I mean, theoretically, you could do it with TIKV, which is open source. I don't know how consensus-y they are.
Okay.
So I mean, yeah. So the competition for etcd within the world of, you know, open source and liberally licensed is weak. It would be good for it to be stronger. Although as a contributor to the etcd project, it would be good if we had more people contributing to etcd itself, right? Because like for some of the etcd's limitations, like, hey, having geographic specific clusters, we'd like to have that in etcd. We just don't have enough people working on it for implementing that to be realistic. And etcd realistically is only the bottleneck for Kubernetes for people who have very large clusters. And by very large, I mean in the thousands of nodes.
Yeah, I don't think I don't really have any issues with etcd, although when I played with it, God, it's probably been more than 4 years. If you want TLS, managing the certificates quickly becomes not so easy.
Yeah, that's done through automation these days.
Right.
I mean, that's one of the things that has improved a lot in the last 3 years, where, you know, we just built in automation into things like Kubernetes and kubadmin that manage that for you. So yeah, no, it used to be really bad. Kelsey Hightower back in the day created this thing called Kubernetes the hard way, which was, you know, effectively, how do I build my Kubernetes cluster from source, you know, and implement every single step myself by hand. And it was an important thing to do because it actually showed how difficult things were and how many things still needed to be automated. And if you look at the series of steps there, an awful lot of that, like possibly half your work in total, is certificate management.
Right, and I'm sure I'm not alone at feeling the pain of things that have happened with OpenSSL over the last 10 years.
Yeah.
That's another space where it would be nice if there was a competitor. But, yeah.
Yeah, well, and I would, from my perspective, it would be nice because it would mean that, you know, the most likely competitors are databases that are currently proprietary, and it would mean that probably those databases were open source, which would be good on the whole. Like, I was very disappointed when CockroachDB stopped being open source because it was a distributed consensus database that spoke the Postgres protocol, so I was very interested in it and was using it for a number of things. But they're a startup and they have a business model.
Yep, and it's not the same as Red Hat's business model.
Yep.
Do you think perchance that Postgres might pick up that kind of mantle, or just for curiosity's sake?
Well, I mean, you could use Postgres as your storage for Kubernetes. Somebody did that as kind of a demo sort of joke thing, right? Because you basically have a single Postgres table that's very simple, you know, and particularly when Postgres started natively supporting JSON, including indexing JSON, it became entirely possible. The problem is that for whatever is going to be your backing store for Kubernetes, you want that to be a distributed consensus store. And there isn't currently a native distributed consensus store for Postgres that is designed for throughput. The consensus version of Postgres that are out there are mainly in the big data realm, which is different than the sort of sets of needs that we need for something that's going to be handling all of Kubernetes API calls. And like I said, that was why I was so interested in CockroachDB, right? Because that kind of was our alternative in that realm.
Right.
So could it happen, right? Could somebody actually release a consensus-based version of Postgres that's production quality? Because there's been a few that have been not production quality in the future. And that could be an alternative for Kubernetes. Absolutely. There's just not one out there right now. And I would say same thing with MySQL.
Right. Any other questions or whatnot? If not, I would like to remind folks